back to my YouTube channel. I am Moses Oluwasegun, and this is Program Mathematics, a YouTube channel where you learn and also teach mathematics. Yes, I said learn and teach because you are going to learn from me. I'm also going to learn from you. Okay, so if you have not been following, I've been discussing matrices. Matrix is a playlist on its own. So when you open the channel, you can also see some other aspects of the matrix that has been discussed before now. Alright, so in the last discussion, the last video, I explained the part of addition of matrices. And I told you that for you to add matrices together, if you are given matrix A, Ij, you want to add this to matrix B, Ij. Okay, so in this case here, we simply add the elements A, Ij and B, Ij together. Alright, so which means that the elements are added according to their location in each matrix. Okay, so and then we're able to look at one or two examples on that. So as a form of revision, let's take this example quickly. Okay, let's assume that I have, if matrix M is the matrix M is 1, 2, 4, 8, and matrix N is let's say -2, -3, 4, -4, -5. Okay, so we want to find the sum of M transpose plus N transpose. Okay, this, and at the same time let's find M plus N transpose. Okay, so let's assume we have this as a problem to solve. This is not a difficult thing to do. So we have matrix M, okay, plus, okay, matrix M first. Matrix M is 1, 2, 4, 8. Matrix N is -2, -3, -4, -5. So we need to find matrix M transpose plus matrix N transpose. So we say M transpose plus N transpose. The transpose of matrix M simply means exchange of rows for columns. So the row 1 becomes column 1, row 2 becomes column 2. So we write that out first. Row 1 becomes column 1, meaning 1, 2. Row 2 becomes column 2, meaning 4, 8. Plus, in case you haven't forgotten this, you can see some previous videos on transpose of a matrix. Okay, so you get to understand this in detail. Then, transpose of matrix N, -2, -3 become this first column, -4, -5 becomes the second column. So let's add these two together. This is saying 1 plus -2, that's -1. 4 plus -4 is 0. 2 plus -3 is -1. 8 plus -5 is +3. So M transpose plus N transpose will give us this. Then what about the M plus N transpose? M plus N transpose. So what this is simply saying is we had matrix M and N together. Whatever we get, we transpose it. So if we do that here, matrix M is 1, 2, 4, 8. 1, 2, 4, 8. Okay, we are doing everything straight. Plus matrix N, -2, -3, -4, -5. So this we bring together into one bracket and transpose the result. Okay, so this will mean 1 plus -2 is -1. 2 plus -3 is -1. 4 plus -4 is 0. 8 plus -5 is 3. So when we transpose this, the transpose of this matrix will mean exchanging the row for column. So this -1, -1, 0, and 3. So if you check the results, okay, -1, 0, -1, 3. That tells you from here that the transpose of matrix M plus the transpose of matrix N is equal to the transpose of the sum of matrix N plus M. And this is one other property of transpose of a matrix that I mentioned in one of the videos, okay, that I said we will discuss again, that is after discussing addition of matrices. All right, so in this case here, transpose of matrix M plus the transpose of matrix N will give us the transpose of the sum of matrix M and N. All right, so that is a revision on addition of matrices. So now let's look at subtraction of matrices. Subtraction of matrices. So how do we do subtraction? A subtraction of matrices too different from that of addition? Yes, it's different. Different in the sense that addition and subtraction are not the same, but the approach remains the same. The approach remains the same. So I'm looking at subtraction of matrices. Subtraction of matrices. The same way, if we are to subtract two matrices or subtract one matrix from another matrix, okay, we still have to arrange the matrices accordingly, subtract the elements accordingly. So in this case, if I have matrix A given as A11, A12, A21, A22, and matrix B also having B11, B12, B21, B22, okay? So matrix A minus B will simply mean arranging them according to their positions. A11, A12, A21, A22, okay, minus B11, B12, B21, B22. So A11 minus B11, A12 minus B12, A21 minus B21, A22 minus B22. So we have this A11 minus B11, A12 minus B12, A21 minus B21, A22 minus B22. So this is how we subtract matrices. So it's not too different from that of A. Okay, excuse me for that. So it's not different from addition of a matrix, because you can see we subtract the elements according to their location in each matrix. All right, so if that is done, then let's take some examples on this. Let's take some examples on the subtraction of matrices. Subtraction of matrices. So let's say I have here as an example, example 1 on subtraction of matrices. So we want to find let's say P minus Q if, okay, find P minus Q and Q minus P if matrix P is the matrix 1, 4, 2, 0, minus 3, 4, 5, minus 2, minus 1, and matrix Q is let's say 2, 7, 9, minus 2, minus 2, minus 2, 0, 1, 0. Okay, so you can as well pause the video and try to solve this problem yourself to see if you are going to get it right. You should get it right because the approach is not too different from that of addition. Okay, so now let's look at the solution to this. Solution to the problem. Okay, so we want to find P minus Q, P minus Q. Write out matrix P first, then minus matrix Q coming second. So matrix P is this 1, 4, 2, 0, minus 3, 4, 5, minus 2, minus 1, minus matrix Q, 2, 7, 9, minus 2, minus 2, minus 2, 0, 1, 0. Okay? So when we subtract this, 1 minus 1 will simply give us minus 1. 4 minus 7 is minus 3. 2 minus 9 is minus 7. 0 minus minus 2, that is 2. Minus 3 minus minus 2, that's minus 3. Plus 2, that's minus 1. 4 minus minus 2, that's 4 plus 2, 6. Then 5 minus 0 is 5. Minus 2 minus 1 is minus 3. Minus 1 minus 0 is minus 1. Okay, you can see I don't have to write 1 minus 2 again here. Just straight subtraction will give us the answer to that. Okay, so what about the reverse of this operation? So let's look at that. Q minus P. Now we have P minus Q, so let's look at P. Q minus P. We want to reverse the order of arrangement of the matrices. Let's see if our answer will be the same for Q minus P and P minus Q. So Q minus P will mean we write the matrix Q first. Our matrix Q is 2, 7, 9. Minus 2, minus 2, minus 2, 0, 1, 0. Minus matrix P. Matrix P is 1, 4, 2, 0, minus 3, 4, 5, minus 2, minus 1. So straight subtraction also from here. 2 minus 1 is 1. 7 minus 4 is 3. 9 minus 2 is 7. Okay, then minus 2 minus 0 is minus 2. Minus 2 minus minus 3, that's minus 2 plus 3, that's 1. Minus 2 minus 4 minus 6. 0 minus 5 is minus 5. 1 minus minus 2, that's plus 3. Okay, then 1 minus minus 1 is 2. Alright, so if we look at the result we have here, you can see they are not in any way the same. Okay, they are not in any way the same. Okay, so because here we have 1, 4, 2, 0, minus 3, 4, 5, minus 2, minus 1, that's for matrix P. Okay, I mean for P, then Q, 2, 7, 9, minus 2, minus 2, minus 2, 0, 1, 0. So this minus this, all of this, we have that here. Okay, so which is not the same here? Okay, it's not the same thing at all. Okay, so let's check this again. 2 minus 1 is 1. 7 minus 4, 3. 9 minus 2, 7. Minus 2 minus 0 is minus 2. Minus 2 minus minus 3, 1. Minus 2 minus minus 4, minus 6. 0 minus 5, minus 5. 1 minus minus 2 is 3. 0 minus 1. Minus minus 1, this is 1. Alright, so that's what I'm trying to check. Because the Q minus P and P minus Q, okay, they are just inverse of each other. What that means here in this case is that Q minus P is not the same as P minus Q. And so, unlike addition of matrices that is commutative, subtraction of matrices is not commutative. So Q, I can conclude that yes, since this is not equal to this, then matrix subtraction is not commutative. Is not commutative. Okay? So subtraction of matrices is not commutative. Alright? So that is that. So if this is your first time of coming in contact with this YouTube channel, this is programmed mathematics. I am Moses Oluwasegun Walex. I'm the tutor on this YouTube channel, and so I want to plead with you to please subscribe to this YouTube channel, like the videos, give me thumbs up on the video, comment using the comment section. If there's need for you to reach out to me personally, in the video description you'll see my contacts there, my phone numbers, my call number, the WhatsApp, my email also. You have all of them there. You can reach out to me through those contacts. Okay, so please, I would love you to also recommend this channel to your friends, your relatives, everyone around you, so as to be able to reach other larger audience. Okay, so thank you so much. Now, before you go for today, I need you to do this as an assignment. Okay, so I want you to do this as an assignment. So in the next video, we shall be getting the solution to this. Now the assignment is this. Okay, number one. Okay, you have to show whether or not A or M transpose minus N transpose is equal to M minus N transpose. Okay, you can decide that. Use any matrix of your choice. Okay, if you want to go by 2 by 2, 3 by 3, or whatever dimension, so long M and N, they have the same dimensions or order. And number two, you have given that matrix P is X minus Y, and then this one is let me say X minus M, and this is X plus Y and Y minus N. There's matrix P. Matrix Q is the matrix. Matrix Q is the matrix 1 minus Y. Okay, 1 minus Y. Then we have 5. Then, okay, we have X. Let me just say this one is 8. Okay, then Y minus N, we have 3. Okay, let me just put it this way. Let's just make everything numbers here. And P minus Q is the matrix. P minus Q is the matrix 9. Okay, 9. And this one is 6. Okay, 6. And then this one here is M, and this is 2N. Okay, so find M, N, X, and Y. Okay, so that is the question. So you are given matrix P, matrix Q, P minus Q. So find M, N, X, and Y values. Alright, so that's the question there. So with this, I'll conclude the subtraction of matrices. So in the next video, I'll be teaching the multiplication of matrices. Okay, and in that case, before that, I'll be talking about scalar multiplication of a matrix. Okay, so let's see in the next video. Thank you.